Hi everyone, this is Eugene Lisho. Today I'd like to show you a little bit about CloudCompare. And if you don't know what CloudCompare is and you're working with scan data, I think you'll find it an extremely useful tool. This is a little open source project that began in about 2004 from Daniel Giradeau-Montaut in France, and it's used for 3D deviation analysis and also for registration. It's freely available and is a great tool. If you're interested in getting it, you can look for it right over, let me bring this up on my screen right here. So at danielgm.net/cc, and you can just download it from here. So again, this is something that is used to compare point cloud to point cloud or a mesh to a point cloud, and it has a number of useful tools. I'm just going to give a very preliminary look at how you can quickly get 2 point clouds in and do a quick comparison. I have to say that I am rather new with CloudCompare, so I've got the basics down, and there's probably a lot more in-depth tutorials that could be done and a lot more features here, but I'm just going to stick with the basics because that's what I'm comfortable with. So the first thing that we need to do is open up a couple of point clouds. So I have 2 point clouds. I'm just going to select them both and open them. And on the importer here, you'll see I've got XYZ coordinates. There's a scalar field, which is the intensity, and RGB. So I'm just going to hit OK. So this will start to import the first one. And once that's in, I'll do the second one immediately. So it's in the same format. So I'm just going to hit OK. And this will come in as well. Now you'll see that on screen the scalar is what's being shown. So the intensity is what is actually being shown. So I'm going to get rid of that. These are color scans, so there is RGB information. So if I highlight the first scan here, the garden one, this is going to be our reference scan, let's say, and I scroll down here just a bit, you'll see that it's now currently showing the scalar field. I'm just going to go to none, and you'll see I start to get color, and I'm going to do the same thing for the second one. I'm going to scroll down, go to scalar field, and hit none. Okay, so both there. Now you can make these visible or not just by checking them off and on. And I'm just going to zoom in and show you what I've got here. So this is the second one that I did, and this is just a garden here. And I just, well, let me go back to the first scan. The first scan is just a, sort of dirt in the garden, nothing special, like so. And on the second one, what I did was I took a shovel and I started to dig out a little hole, let's say, made a little depression in here that you can see from the side view. So we want to compare these two, and of course this is something that you could do with any kind of terrain or pits or mines, whatever. I'm sure there's a number of things you can think of where surfaces are changing. So right now they're in this position. This is the position that they came in. These are both in meter units, but CloudCompare doesn't actually deal with, or you can't actually set the units, so whatever it comes in with, they should have the same scale units already. Now, I can start to register these right off the bat, but if I wanted to, there's a couple of useful tools. So if I go onto the base reference one here, there's an option here for translate rotate. So when I click this, now instead of rotating, what I'm actually going to be translating when I start using the mouse tool. So it's not just the view that I'm rotating, but the actual object. So when I right click and I move up and down, I'm actually moving the scan closer and further away to the other scan. So I'll move it up a little bit like that, and I can also rotate it. If you see, I can rotate it with respect to the other one. So that's one way you could bring the two scans together. So I'll just accept that for now. They're close enough. Now there is another way to do this through the matrix here, and I'm just going to show you that it's here. Apply transformation. So there's a matrix here that we can change certain things, and there's actually in the help files right here, you'll see that it gives some information on what each of these values is. So that's something that if you're into, you can use as well. Alright, so to do the basic registration, what I need to do is click on 2 of the scans. So I'm going to click the first one, this garden 1, and I'm going to hold down the control key and hit the second one, garden 2. And up here on this particular icon is register entities. So I'm going to click on that, and this little menu comes up. So right now my model, or my base, my reference scan is CloudCompare Garden 1, that's fine, and then the data that it's going to be compared to is Garden 2, which is fine. That is what I wanted. Now the error difference, if you want to make this more fine, you can make this a lot smaller. So if I wanted a really small value, I'm going to have it down to 1 to the minus 20, and the random sampling limit. So it's going to sample a number of points, 20,000 points. Now, if I want to sample more of the points, I can, so I'll set this to something like 60,000. And of course, the scans themselves contain well over 1 million points each. So if I set this value to 1 million, then I would be sampling almost all the points in the point cloud. But we're going to do something a little less just to make it quick. So I'm going to hit OK, and this should start to go through iteratively and try to get the errors, the mean square errors, down as small as possible. So we'll just wait and see what happens once it goes through here. Okay, so that wasn't too bad. So you can see both scans are now aligned to each other. They're one on top of each other. So hard to tell them apart actually, because it almost looks like one of them. But in fact, they're both visible, so they're both there. So that's the registration. Now, because these two scans are very similar, if you're going to be registering scans that are dissimilar, very dissimilar, you may find that you have some problems. And some of the things that you can do, let me just go back, and I'll just leave the base one on, is you can also edit the scan. So if I select the base scan, there's a button here for segmentation. So if I click on that, I can actually choose, for example, a polygon selector, and I can go through and cut out a piece. So what I would recommend, and I'm not going to show it to you here, but if you have two dissimilar point clouds, but part of them are the same, cut out the section that is dissimilar and leave just the parts that are the same, register them, and then apply the same transformation to the part that you had cut out. So I know it may sound a little bit confusing. I'm just going to segment this out, and you'll see that it's disappeared out of here. Okay, and then if I wanted to, I could confirm that, and it'll show up as a separate scan here. But I'm not going to do that. I'm going to cancel this out. I don't want to do that. But I'm just giving you some hints here. Okay, so yeah, and I showed you some of the segmentation tools. I'm going to turn both clouds back on, and now what I'm going to do is a cloud-to-cloud comparison. So again, I'm going to control-click. So I've got both of these scans selected. And over here I've got a cloud-to-cloud distance or comparison. Now you can also do, over here you've got cloud to mesh distance. So if you were to bring in something like a CAD model that was a reference, and then you have a scan that's of an actual part, well, you can do a comparison. But we're just going to stick with cloud-to-cloud. So here I've got the reference is 2. Well, I'm going to swap that because my base was the one that had the sort of the more level garden soil, and then garden 2 was the one where I actually dug out a little depression or a hole. So I'm going to hit OK, and it's going to go through and do a little something here and set it up, and you can see already that we've got a little bit of deviation showing here. Okay, but I need to set some things here before I can hit OK, and I need to compute. So I normally choose octree level at 8. You can experiment with some different values, but again, I'm not very familiar with some of these local modeling, and I was told once to use octree level 8, and that seems to be working for me. Probably in another tutorial I'll dig in a bit more and figure out what all these things do. But if you hit the compute button, it will now go through it and do the analysis on all the points, and you can see it's already done. I'm going to hit OK. Once I do that, if I deselect everything, you see I've got the actual one model in here and also the deviated model. So what I'm going to do is I'm going to see which one that is. I'm going to turn one off, and now I've got this 2, the second one up here. So we have some things that we can play with, we can set. And if I go down to here, if I scroll down, you see I've got some things here that I can play with, but the one I'm looking for, let me just do this here, is display the colors scale. So I'm going to click on that, and up on my screen is a color scale showing what the colors represent in terms of the actual values of deviation. So let me zoom out a bit so you can see that. Okay, now if I take the sliders that were up here, the top one will show what is displayed. So as I start to turn this down, some of these things are going to start to disappear in terms of color. But because they're very similar, what I'm going to do is I'm going to adjust the scale. So you'll see if things start getting more red as I change the scale limits. Okay, so I'm going to get it just so I have just a little bit of red at the bottom. Okay, so now the areas shown in red are greater than 12 centimeters or so. And that is basically how you do the deviation analysis. I realize it's a sort of a basic tutorial, but hopefully that will get you going. I should mention that there's some other tools as well on subsampling. This is also useful if you have a very, very big point cloud. There's an icon here for subsampling, and if I click that, you can set the number of points that you want out of this particular point cloud. So if this was a a 15 million point cloud, and I only wanted to work with, I don't know, maybe 100,000 points, I could just set 100,000. It'll do a random sampling. I'll hit OK, and you can see that it's already brought it up here. And I've got a point cloud that is easier to manage for the either the deviation analysis or whatever it is that I might want to do. Okay, well, thank you very much, and hope you learned something. Bye-bye.